negative pi by 4. I just want to just make a general note about plotting things. Okay, this is not an arts course. I know that a lot of people go into math because they don't like drawing, but we're going to expect you to draw some stuff. Okay, there's going to be drawing points. There's going to be drawing curves. There's a whole range of artistic abilities. So what we'll ask you to do on quizzes and tests and things is to label the point that you drew. Okay, so on the sample quiz, you'll see it says label 3 points. Okay, we want you to label the point that you drew so that we know what you're trying to draw, what point you're trying to convey. Okay, so we've got 7 negative pi by 4, and for negative 7 negative pi by 4, we go negative pi by 4, and then we go in the opposite direction.
So the order in which we do it is also matters, right? Because if I did like negative 7 and then negative pi over 4, then it would be something else.
Right, yes. So you turn your radar to the angle and then you measure the distance. Yeah. So angle, distance. Questions there, comments before we go on? So, oh yes, sure.
So is 7 pi by 4 the same form as minus 7 5 pi by 4?
Yes. Yeah. Yeah. Good observation. Yes. Yeah. So the observation was, if I add a negative sign to the radius and pi to the angle, am I at the same point? And the answer is yes. Yeah. Cool. So now we're going to think a little bit about how to convert between polar and Cartesian and back. Okay, so if we want to go from polar coordinates to Cartesian, right, then we have to do a little bit of trigonometry. We have to figure out where our point will lie. Right, so if we've got a diagram like this, we go up theta, across to r. So we want to figure out the, now we're thinking Cartesian coordinates of this point here. Suggestions, thoughts about how we can get x and y? Yeah? Yeah. We can do some trig, right? We've got this right angle triangle. It has hypotenuse r. Right, so we can use trig to get us x is cos times hypotenuse. point, we can get its Cartesian coordinates by using trigonometry. And now we want to work the other way. We want to work backwards to go Cartesian to polar. So we've got a point in Cartesian coordinates, and we want to find out the corresponding point in polar coordinates. So the first thing we have to do is we have to measure this length, right, to figure out r. That's fine. So I'll take the distance from x, y to 0, 0. And now there's a bit of subtlety with the angle. Okay. Can anyone spot what makes calculating the angle difficult? Yeah, sure. Yeah. First of all, there's an inverse trig function. What else is going on that could make getting this angle difficult? Yeah. How many times do you want to go around? Yeah, exactly. We've got this ambiguity about what theta should be, right? So there's many, many different answers for what theta could be. Okay, other difficulties, other observations? Yeah, sure.
Oh, like if we don't know, like if it's like in the negative quadrant, like we don't know which quadrant.
Right, yeah, there's sort of quadrant issues. Yeah, so there's a lot going on here. So the first thing is so we want this inverse trig, right? We want to use inverse trig here. So let's use tan. We'll say this is opposite over adjacent. Okay. Where will this formula blow up? Yeah, if x equals 0. Okay, so tan inverse will take care of everything that we want, unless x is 0. If x is 0, what is our angle? Yeah. So if x is 0, then we're somewhere along here. Right, so this is the line x is 0. Okay, so we are either somewhere up here and theta is pi by 2, or we're down here and theta is 3 pi by 2. Okay, so we can get into this slightly ambiguous situation, right? So this formula works for all values of x and y, unless x is 0. If x is 0, you have to look at this diagram and figure out, am I up here or am I down here? Okay, so let's actually convert some things to and from, and we'll see where the issues are. Okay. Everyone got those formulas? Alien laptop guy, you got it? Yeah. Good. kind of one sort of like philosophy point before we go on here. This is the first new coordinate system we've seen. It's kind of cool. Like when we want to describe a position on this blackboard, say, right, we've got choices. We can choose it to describe it in Cartesian coordinates, or we could choose to describe it in polar coordinates. Right, we've got a two-dimensional surface. We can describe things in terms of angles and lengths, or in terms of x's and y's. Interesting. Later on, we're going to see infinitely many different coordinate systems. We're going to see that there's any kind of coordinate system you want. We're not there yet. So we'll convert. In the direction polar to Cartesian, we have a formula. We get here. Okay, now we can calculate out these special values of trig. And then this guy and this guy cancel. So 1, 1. Okay, now let's go in the opposite direction, the direction Cartesian to polar. Let's take 2 minutes, try and calculate this out. Try and figure out what point this is in polar.
Right. Yeah. Yeah, I'll go ahead and
Okay, does anyone want another moment with that? Is anyone still calculating? Okay, oh yeah, you want another moment? Okay, who's got a final answer? Yeah, okay, sweet. Awesome, okay, good, so we'll take another moment. So the purpose of these things is like the lowest stakes test on earth, right? Like, no one's gonna know if you got it right or wrong, except you. That's it. It's super duper duper low key. Okay, this is an opportunity for you to try out, do I really understand this nonsense? Okay? So I highly encourage you to try these calculations